Okay, this video is for the standard number 3, use technology to find prediction equation correlation coefficient. Level 1, 2, 3, 4 is based on how many parts there are. So the 4 things you need to complete in order to be perfect on the standard is prediction equation, make a prediction from the equation, find the correlation coefficient, interpret the correlation coefficient. This is one question that has 4 parts to it. So you just got to make sure that you pay attention to what you type in, double check, and be great at the amazing work that you can do. So the first thing is called a scatter plot or a dot plot. It's a bivariate data graphed as ordered pairs. The dots are not connected, so not a continuous function. There are 3 types of correlations. You have no correlation, negative correlation, and positive correlation. So data that has no correlation is data that has no set process to it. It's just a bunch of random dots. Negative correlation is data that forms a negative line. So the data follows a negative process. And then positive correlation is the data that forms a positive slope or correlation of the data. So you got sparsed, spread it out. Negative correlation, you can form a negative slope or a negative line. And positive correlation, there's some positive line, and you can't really draw a line to connect the data. So the next thing we have is called a line of fit. So these 2 lines here would be considered a line of best fit. Excuse me. So it's a line that closely approximates a set of data. So it's a line that allows your data to be foreseen or seen as a linear, oh my gosh, a linear model, excuse me. So prediction equation, regression line, which is really the line of best fit, but the prediction equation is the equation for the line. It predicts one variable can be made for the other variable, so you make an input and an output. Correlation coefficient. The correlation coefficient is your R value, which we'll talk about here in a second. That will be equal to -1 or between the range of -1 to 1 or equal to 1. And it's a measure that shows how well the data is modeled, or how well data are modeled by the linear equation. When R is negative, you have a negative correlation. And when the value is between -0.9 to -1, it is strongly accurate or strong/accurate. When R is equal to 0, there's no correlation between the data. When R is positive, you have a positive correlation. And when it's between the values of 0.9 to 1, it is strong and accurate, or strongly accurate. So the next part is a set of information that we're going to go over in the second part of the video, and we'll go through the process.